Alright, my fellow cosmic drifters, settle in. Welcome. Find that perfect little hollow for your head, let your shoulders soften, and breathe. Just breathe. Tonight, we're not just gazing at the stars as they are, static and serene in our brief moment of now. No, tonight, we're pulling back the rather grand, perhaps slightly moth-eaten velvet curtains on the next 100 years of our relationship with this vast, bewildering universe. A century that humanity, in its charmingly persistent way, anticipates with bated breath, sketching out blueprints for progress, for discovery, for making its mark. A cosmic to-do list, if you will. It promises to be quite the show, cosmically speaking. Or, just another blink-and-you'll-miss-it Tuesday for the universe itself, which, let's be honest, has seen empires rise and fall with considerably less fanfare than we attach to launching a new satellite. You can almost feel the hum of anticipation, can't you? The restless energy of a species that can't quite sit still, always peering over the next horizon, even if that horizon is light years away and utterly indifferent to our arrival. We dream of new worlds, of answers to age-old questions, of finally figuring out if we're truly alone or just particularly bad at finding the cosmic party. There's a certain grandeur to this ambition, a spark that refuses to be extinguished by the overwhelming darkness or the crushing silence that often greets our most profound queries. We look up and we plan. We calculate. We build ever more elaborate toys to fling into the void, hoping one of them sends back a postcard that makes a lick of sense. And as you lie there, drifting, feeling the gentle pull of sleep beginning to tug at the edges of your awareness, let's allow ourselves to indulge in this forward glance. But let's do it our way, shall we? Not with the breathless, uncritical optimism that papers over the rather large cracks in the facade of cosmic harmony, but with a knowing smile, a raised eyebrow, and perhaps a quiet chuckle at the sheer audacity of it all. Because this journey into the next century of cosmic endeavor isn't just about starry-eyed wonder. Oh no. It's also about acknowledging that slight, persistent draft coming from under the universe's door, a draft that whispers of monumental indifference, of timescales that mock our fleeting lifespans, and of realities so stark they make your average existential crisis look like a mild case of indigestion. We call this series Cosmic Bedtime Story, and the bedtime part is crucial. We're here to help you unwind, to let the anxieties of your day dissolve into the grand, impersonal backdrop of space and time. But the cosmic part? That comes with its own unique flavor. It's a beauty so profound it can make your heart ache, yes, but it's also a landscape of such extreme conditions, such casual annihilation, that our terrestrial concerns often shrink to a rather comical insignificance. And there's a strange comfort in that, isn't there? A liberation in recognizing that your overdue bills, your awkward social interactions, your fear of missing out, well, they don't register on the galactic seismograph. Not even a tremor. So, as we embark on this exploration of the top cosmic events that will shape the next century, we'll embrace the awe, certainly. We'll marvel at human ingenuity and the relentless quest for knowledge. But we'll also gently, perhaps even with a touch of dark humor, nudge the unromantic truths into the light. We'll consider what it really means to conquer Mars, a planet that would freeze your lungs solid before you could utter one small step. We'll gaze at the majestic flyby of an asteroid and appreciate the scientific opportunity, while also quietly acknowledging the cosmic game of dodgeball we're perpetually playing, mostly by sheer dumb luck. The grand dreams we speak of are not just about technological triumphs or newfound knowledge. They are also dreams of understanding our place, or perhaps our lack of one, in this staggering expanse. They are about confronting the vastness and not flinching, or at least flinching with a sense of ironic camaraderie. Imagine, if you will, the universe as an infinitely patient, slightly bemused old entity, watching us scurry about, making our grand pronouncements about the future. It's seen comets come and go like celestial punctuation marks in sagas far longer than our own. It's witnessed the birth and death of stars in numbers that defy our comprehension. Our next 100 years? A fleeting sparkler in an eternal fireworks display. And that's all right. In fact, it's more than all right. It's relaxing. Because the pressure's off, isn't it? If our grand cosmic achievements are ultimately just charming, fleeting gestures in an indifferent void, then we can simply enjoy the process, the learning, the sheer, improbable wonder of being conscious entities capable of even contemplating such things. The universe doesn't demand our success. It doesn't require our understanding. It simply is. And we, for a brief, dazzling moment, get to be within it, looking out, looking up, and looking forward. So let your mind drift. Let the everyday concerns become distant stars, faint and unimportant. We're about to embark on a journey through anticipated moments, through celestial appointments and human aspirations. We'll touch upon the beauty, the science, the sheer unlikelihood of it all. And we'll do so with the gentle reminder that even as we reach for the stars, our feet are on a tiny, fragile pebble, and the cosmos is under no obligation to play nice. It's in this acceptance, this wry acknowledgement of the beautiful, terrifying, and often absurd dance between humanity and the universe, that true peace can be found. A peace that allows you to smile softly in the dark, and drift into a deep, untroubled sleep, ready for whatever grand or comically mundane truths the cosmos decides to reveal next. The curtains are open. The stage is set. Let the next century's cosmic overture begin, with all its majesty, and all its delightful, unsettling fine print. And so, our gentle drift carries us forward, through the unfolding fabric of the near future, towards a rather famous appointment, a celestial rendezvous penciled into our cosmic calendars long ago. Picture it, the year is 2061. Many of you listening now might recall stories from your grandparents, perhaps even your parents, of a fuzzy, ethereal visitor gracing Earth's skies back in 1986. For others, it's a legend, a name whispered in astronomy books, a ghost from the solar system's past. We speak, of course, of Halley's Comet. Its return is one of the first major cosmic events dotting our 22nd century timeline, a predictable, yet always somehow magical reappearance. There's a certain poetry to it, isn't there? This dirty snowball, officially designated 1P/Halley, tracing its vast, elliptical path around the sun, a journey taking roughly 76 years. It's a cosmic metronome, ticking off human generations with its ghostly passage. Imagine those who saw it as children in '86, perhaps now elderly, pointing it out to their own grandchildren, a tangible link across decades, a shared sky. It's a beautiful thought, this intergenerational connection, woven by the silent, arcing flight of a comet. We, as a species, seem to crave these connections, these anchors in the relentless flow of time. Halley provides one, a familiar, if somewhat faint, celestial face. You can almost feel the gentle anticipation building across the globe in the late 2050s. Amateur astronomers dusting off old telescopes, news outlets running retrospective pieces, a collective holding of breath for this fleeting spectacle. When it arrives, it won't be a dazzling, sky-splitting behemoth for most naked-eye observers. Its 1986 appearance was, shall we say, a tad underwhelming for the casual stargazer, thanks to its position relative to Earth and the Sun, and the ever-increasing glow of our light-polluted cities. One can only hope that by 2061, we'll have either collectively dimmed our urban sprawl a tad, or Halley itself decides to put on a slightly more dramatic show. Perhaps it's practicing its pirouettes out in the Kuiper Belt, preparing for a grander entrance. One can dream. The beauty of a comet, even a modest one like Halley often presents, lies in its ethereal nature. The soft glow of the coma, that fuzzy envelope of gas and dust boiled off by the sun's warmth. The delicate sweep of its tail, or perhaps two tails, one of dust pushed gently by sunlight and one of ions, sculpted by the solar wind, stretching millions of kilometers across the blackness. It's a whisper from the outer solar system, a transient brushstroke against the canvas of fixed stars. And for a few weeks, a few months, it becomes our comet, a celestial wanderer briefly captured in our collective gaze before it swings back out into the cold, indifferent dark, promising to return when most of us listening now will be, shall we say, otherwise engaged. Or perhaps just cosmic dust ourselves, ready to form the next generation of something or other. Cheerful thought, isn't it? This sense of an appointment kept, a promise fulfilled by the clockwork of orbital mechanics, is deeply soothing. It speaks of order, of predictability in a universe that often feels chaotic and arbitrary. For centuries, comets were portents of doom, harbingers of disaster, cosmic bad omens. Thanks to Edmund Halley and his rather clever application of Newtonian physics, we now see them as old friends, albeit friends who only visit every 7 decades or so, and who tend to shed quite a bit as they travel. It's this transformation from terror to anticipated guest that marks a subtle shift in our relationship with the cosmos, from fearful superstition to a somewhat informed understanding. We've learned its schedule even if we haven't quite figured out its motives, assuming it has any beyond just arcing. Imagine yourself then, perhaps on a cool evening in July or August of 2061, looking up. Maybe you're far from city lights, the Milky Way a luminous river overhead. And there it is, a faint, fuzzy patch, perhaps with a hint of a tail if you're lucky and your eyes are dark adapted. It's not shouting for attention. It's just there. A silent traveler, briefly illuminated for our viewing pleasure before it recedes again into the vastness. You might feel a connection to all those who have seen it before, stretching back through recorded history, to Giotto, who famously painted it into his adoration of the Magi, to the chroniclers of 1066 who saw it blaze before the Norman conquest. You are part of that chain. Yet, as you gaze upon this celestial visitor, it's worth a wry smile to consider that Halley itself is utterly, magnificently, blissfully unaware of its fan club. It doesn't care about our historical records, our paintings, our intergenerational awe. It's a hunk of ice, dust, and rock, a few kilometers across, responding to the inexorable pull of the sun's gravity. Its beauty, its significance, is entirely a projection of our own human consciousness, our pattern-seeking brains, our desire for narrative and connection. It's a stark reminder, even in this moment of gentle beauty, of the universe's profound indifference to our sentiments. It performs its gravitational dance, and we clap from the distant audience, assigning it roles and meanings it never auditioned for. It's like your cat, really? You shower it with affection, interpret its every blink as profound wisdom, and it just wants the tuna. Halley just wants to get back to the Oort cloud for a bit of a nap. So, as it makes its ghostly encore in 2061, we will watch. We will photograph. We will feel that sense of continuity. And then it will fade. Life will go on. The cosmic ballet continues with or without our applause. And that fading, that inevitable departure, is also part of its gentle, sleepy lesson. All things are transient, even celestial celebrities. Their beauty is fleeting, making the moment of witnessing all the more precious, and all the more inconsequential in the grand scheme. Let that thought not be a source of anxiety but of peace. A gentle letting go, like the comet itself, arcing away into the quiet dark, until its next scheduled and utterly unconcerned appearance. For now, the anticipation is a soft glow, a distant promise of a familiar, dusty, icy friend, reminding us that some things at least come back. Eventually. Our gaze lingers on that fading point of light, Halley's Comet, as it begins its long, cold journey back to the outer solar system. We've touched upon its historical significance, its role as a celestial clock, the gentle, nostalgic connection it offers across generations. But let's not get too carried away with the poetry, shall we? Let's wipe a little of that romantic stardust from our eyes and consider what this icy messenger truly is. Because while it paints a pretty picture from afar, up close, a comet is less a graceful ballerina and more of a cosmic dirtball. A very, very old and surprisingly grumpy dirtball, if its occasional outbursts are anything to go by. Imagine shrinking down, becoming a tiny, intrepid explorer hitching a ride on Halley's nucleus. The view of the solar system would be spectacular, no doubt. But the immediate surroundings? Not so picturesque. You wouldn't be gliding on a pristine snowball. Oh no. The surface of a comet like Halley, as missions like Giotto and Rosetta have shown us with other comets, is dark. Surprisingly dark. Often blacker than coal, covered in a crust of organic compounds and dust, the result of eons of baking by sunlight whenever it ventures inwards, and bombardment by cosmic rays in the deep freeze of the outer solar system. Think of it as a deep frozen space muffin that's been left in the galactic oven a bit too long on one side, and then rolled in soot. Appetizing, no? And this dark, dusty crust covers a core of ices, water ice, mostly, but also frozen carbon dioxide, methane, ammonia. Primordial stuff, leftovers from the formation of the solar system, some 4.6 billion years ago. These are the building blocks scientists get so excited about. And rightly so from a purely academic standpoint. These comets are like time capsules, preserving the ancient chemistry of our solar system's birth. They may have even delivered some of Earth's water, and perhaps even some of the organic molecules necessary for life, in the chaotic early days of the solar system. A sort of hazardous interstellar FedEx, if you will, occasionally delivering life-giving parcels and other times, well, delivering rather large rocks at inconvenient velocities. The universe, it seems, doesn't do gentle postage. As Halley gets closer to the sun, this ancient, icy heart begins to stir. The increasing solar radiation heats the surface, causing those trapped ices to sublimate, to turn directly from solid to gas. This is what creates the coma, that fuzzy atmosphere we see, and the spectacular tales. But it's not a gentle, misty process. It's often violent. Jets of gas and dust can erupt suddenly from fissures in the crust, like cosmic geysers, sending plumes of material hurtling into space. Imagine standing on this thing as it wakes up. It would be like trying to have a picnic on a faulty firework. One minute you're enjoying the view, the next, a plume of ancient methane and dust shoots out from under your feet, flinging you off into the void. Not exactly a recipe for a relaxing afternoon. So, while we admire the fleeting yet memorable beauty from a safe distance of millions of kilometers, let's not forget the comet's more inconvenient truths. These are not just serene wanderers. They are active, dynamic, and somewhat crumbly objects. They shed constantly. The dust and debris left behind in a comet's orbit create meteor showers when Earth passes through them. Halley, for instance, is responsible for the Eta Aquariids in May and the Orionids in October. So, when you see a shooting star from one of these showers, you're witnessing a tiny piece of Halley, no bigger than a grain of sand or a small pebble, burning up in our atmosphere. A little wave from the comet, or perhaps just cosmic littering on a grand scale. It's all about perspective. And let's not entirely gloss over that occasional impacts part. Comets and their rocky cousins, asteroids, have shaped the history of planets, including our own, in rather dramatic fashion. The Earth bears the scars. The dinosaurs famously had a rather bad day thanks to a large impactor. While Halley itself is not on a collision course with Earth, its orbit is well understood and poses no threat. Its brethren are out there. Trillions of them, lurking in the Oort cloud, that vast spherical shell of icy bodies far beyond Neptune. Most will never trouble us. But occasionally, a gravitational nudge from a passing star or some other cosmic jostle can send one of these icy behemoths hurtling towards the inner solar system. It's a humbling thought, isn't it? That the same objects we admire for their ethereal beauty, the same objects that may have seeded our planet with the ingredients for life, are also members of a celestial population that could, with little warning, erase civilizations. The universe, giving with one hand and holding a very large, icy rock in the other, certainly keeps things interesting. Or terrifying. Or, if you're sufficiently detached and sleepy, just cosmically ironic. So, as Halley recedes in our mind's eye, let's appreciate it for what it is. A fascinating, ancient, somewhat volatile relic of our solar system's birth. Beautiful from afar, certainly. A vital scientific resource, undoubtedly. But also, a gentle reminder of the raw, untamed nature of the cosmos. These aren't celestial swans gliding gracefully through the void. They are icy, dusty, outgassing remnants, occasionally shedding bits of themselves, sometimes in spectacular fashion, and every now and then, one of their larger, angrier relatives reminds us that the solar system is still, in many ways, a cosmic construction site with rather lax safety regulations. And as you drift deeper into relaxation, perhaps you can feel a tiny bit of gratitude for the vast, empty spaces between us and most of these grumpy, shedding ice mountains. It's the emptiness sometimes that keeps us safe. Sweet, isn't it? The profound silence and cold indifference of space, occasionally punctuated by a pretty but fundamentally messy visitor. From the fading tale of a relatively harmless, if somewhat messy, comet, our journey through the next century's cosmic highlights now takes a rather significant leap in ambition. We shift our gaze from a passive celestial observation to an active, audacious human endeavor. We're going to Mars. Or at least that's the plan. The dream of setting human footprints on that dusty red surface is deeply ingrained in our collective imagination, a science fiction staple slowly, painstakingly, attempting to inch its way into reality within the next 100 years. The red planet, a beacon of hope for some, a monumental folly for others, but undeniably a powerful lure. You can almost hear the rumble of the launch vehicles, feel the thrum of anticipation. The courage of exploration, as it's often framed, propelling us towards this rusty-hued neighbor, is the next logical step, they say. The dawn of a new era, they proclaim. And there's a certain romanticism to it, isn't there? Those first images, beamed back across millions of kilometers, a gloved hand touching Martian soil, a flag planted, again with the flags, the breathtaking panorama of an alien landscape. It's a powerful narrative, one that speaks to our innate human desire to explore, to push boundaries, to boldly go where robots have already gone quite successfully and far more cheaply, but never mind that. Humans need to be there, apparently. We need to smell the highly toxic roses. But as you relax, as your breathing deepens, let's gently peel back the glossy brochure image of Mars exploration and peer at the rather stark realities that lie beneath. Mars is not Earth's friendly twin, patiently awaiting our arrival with open arms and a breathable atmosphere. Mars, to put it mildly, is a profoundly hostile place. It's a planet that, if it were sentient, would seem to be actively trying to discourage visitors, perhaps even to exterminate them with extreme prejudice. It makes your most challenging holiday destination look like a 5-star spa resort. Imagine stepping out onto the Martian surface. The first thing that doesn't happen is a refreshing breath of air. The atmosphere is about 1% as dense as Earth's, and composed mostly of carbon dioxide. You'd asphyxiate in moments without a suit. Not a gentle drifting off, more of a rapid, unpleasant, lung-emptying kind of affair. Then there's the temperature. While equatorial regions can reach a balmy 20 degrees Celsius, 70 Fahrenheit, on a summer day at noon, the average temperature is a bracing -63 Celsius, -81 Fahrenheit. Nights plummet to unimaginable cold. Your spacesuit would need some serious insulation and a very, very reliable heater. One power failure and you become a human popsicle faster than you can say, "Houston, we have a problem." And the dust. Oh, the Martian dust. It's finer than talcum powder, abrasive and likely toxic, full of perchlorates. It gets everywhere. It would clog seals, scratch visors, irritate lungs if any gets inside the habitat. It's not the charming rustic dust of an old farmhouse. It's insidious, pervasive, and potentially carcinogenic. So, not only is the planet trying to freeze and suffocate you, it's also trying to give you a nasty cough and possibly worse down the line. Delightful. Then there's the radiation. Mars lacks a global magnetic field comparable to Earth's, and its thin atmosphere offers little protection from galactic cosmic rays and solar particle events. Astronauts on a long-duration Mars mission would receive radiation doses significantly higher than on Earth, or even on the International Space Station. This increases the risk of cancer, cataracts, and potentially impacts the central nervous system. So, you're freezing, choking, covered in irritating dust, and slowly being irradiated. The brochure probably leaves that bit out, nestled somewhere in the very, very fine print. And let's not forget the psychological toll. Months, perhaps years, in a confined habitat with a small group of people millions of kilometers from home. The Earth, a distant blue marble in the black sky. The communication delay making real-time conversation impossible. The constant awareness of the thin wall separating you from a lethal vacuum. The sheer, crushing monotony, punctuated by moments of sheer terror if something goes wrong. It takes a special kind of resilience or perhaps a special kind of denial to volunteer for such a mission. One hopes they pack a very good therapist, or at least a very, very extensive library of cat videos. So when we talk about those first footsteps, the dawn of a new era, let's remember the immense challenges, the profound risks, the sheer, bloody-minded determination it will take. It's not just a hop, skip, and a jump. It's a monumental undertaking, pushing the limits of technology, human endurance, and arguably human sanity. The courage is undeniable. The engineering prowess will be breathtaking. But the dream of conquest, as it's sometimes phrased, Mars will not be conquered. It will, at best, be grudgingly tolerated, a temporary, heavily fortified human outpost on an alien world that remains fundamentally, deeply, and irrevocably hostile to unprotected life as we know it. As you drift towards sleep, imagine that silence on Mars. A silence broken only by the hum of machinery, the whisper of wind, what little there is, and the thumping of your own heart within your suit. A profound alien silence. It's a testament to human ambition, yes. But it's also a testament to the universe's vastness and its utter indifference to our particular brand of biological fragility. The red hope is also the red headache, a beautiful, dangerous, and ultimately alien world that will extract a heavy price for every footprint we leave in its rusty dust. And somehow, acknowledging that stark reality makes the dream not lesser, but perhaps even more human. Flawed, audacious, and stubbornly reaching for the inhospitable stars. We're still there in our drifting thoughts on the ochre plains of Mars, contemplating those first tentative human footprints. We've acknowledged the sheer bone-chilling hostility of the place. The thin air, the lethal cold, the pervasive, irritating dust, the relentless radiation. It's not exactly prime vacation real estate, is it? And yet, the narrative quickly escalates, doesn't it? From those first footprints, the conversation in the hopeful corners of human aspiration invariably turns to colonization. Martian real estate. A new frontier for humanity. Establishing a permanent presence. It sounds grand, almost manifest destiny on an interplanetary scale. But let's, just for a moment, as you sink deeper into your comfortable state of near sleep, consider the rather amusing hubris wrapped up in that concept. Martian real estate. A buyer's beware of truly cosmic proportions. Imagine the sales pitch. For sale, charming fixer-upper on a serene red planet. Excellent views, unparalleled privacy, you'll be millions of miles from your nearest terrestrial neighbor, and likely any other sentient life. Needs a bit of TLC, namely, a fully enclosed, radiation-shielded, pressurized, heated habitat with its own oxygen supply, water recycling system, and 24/7 life support. Minor atmospheric issues, 95% CO2, negligible oxygen. Occasional planet-engulfing dust storms may obscure views and coat solar panels. Soil requires extensive detoxification before use in agriculture. Gravity is about 38% of Earth's, great for your joints, perhaps less so for long-term bone density. Bring your own breathable air. Seriously? No, really seriously. It doesn't quite roll off the tongue like ocean views and a charming patio, does it? The idea of colonizing a planet that seems so actively designed to repel life as we know it is a fascinating testament to human optimism, or perhaps our species-wide inability to read the room. We arrive on a world where the very ground beneath our feet could be laced with perchlorates toxic to thyroid function, where the air is unbreathable, the water locked up as ice or brine, and the sunlight itself carries a higher dose of cancer-causing radiation, and we think, yes, let's build a suburb here. It's like deciding to set up a permanent beach umbrella in the middle of a Category 5 hurricane because you quite like the dramatic wave action. Admirable dedication to an aesthetic, perhaps, but questionable survival strategy. Consider the sheer resources required. Every nail, every circuit board, every packet of freeze-dried coffee, initially, would have to be launched from Earth on a months-long journey at staggering expense. Growing food? That'll require closed-loop agricultural systems, heavily shielded from radiation, with every drop of water recycled with near-perfect efficiency. One failed pump, one contamination, and your Martian farmers are looking at a very bleak and very short harvest season. It's not like you can just pop down to the local intergalactic hardware store if your atmospheric scrubber breaks down. The supply lines would be the longest and most tenuous in human history. Talk about supply chain issues, your Amazon Prime delivery from Earth is going to take about 9 months, and the shipping cost will be astronomical. Literally. And what about the colonists themselves? What kind of society emerges in such an extreme, isolated, and unforgiving environment? Generations born on Mars would never know the feel of Earth's rain, the scent of a forest, the sight of a blue sky teeming with clouds. Their bodies might adapt to the lower gravity in ways that make a return to Earth physically challenging, even dangerous. They would be a new branch of humanity, forever tied to their fragile, artificial oasis on a fundamentally alien world. There's a certain melancholy beauty to that, a poignant isolation. But also, a profound dependence on technology, a life lived perpetually on the edge, where a single catastrophic failure could mean the end of the entire tiny Martian civilization. It's a high-stakes game of survival played out on a planetary scale. The romantic vision of hardy pioneers taming a new frontier bumps up hard against the reality of highly trained specialists huddled in meticulously engineered habitats, their lives governed by the unwavering laws of physics and biology in an environment that offers no margin for error. This isn't about rugged individualism conquering the wilderness. It's about collective discipline and advanced technology holding back the relentless hostility of an entire planet. The frontier spirit might be there, but it'll be wearing a hermetically sealed suit and triple-checking the CO2 scrubbers. Less Little House on the Prairie, more The Martian on a permanent and frankly, much more stressful basis. There's an irony too, isn't there? We dream of escaping Earth's problems, of a fresh start, yet we'd be carrying all our human baggage, our ambitions, our flaws, our societal structures, to a place that is infinitely less forgiving of them. Any societal cracks, any resource shortages, any human conflicts would be amplified 1,000-fold in that tiny, pressurized bubble. Mars won't offer an escape from ourselves, only a more challenging arena in which to be ourselves. Perhaps the universe is trying to tell us something with these profoundly inhospitable worlds. Maybe the lesson isn't about conquering them, but about appreciating and taking better care of the astonishingly rare and precious habitable one we already occupy. A radical thought, I know. So, as the idea of Martian subdivisions and interplanetary commutes drifts through your mind, let it be accompanied by a soft, sleepy chuckle. The audacity is magnificent. The engineering challenges are profound. But the notion of truly colonizing Mars in the next century, in any way that resembles our terrestrial understanding of the word, is perhaps one of our grandest and most amusingly bleak cosmic jokes. A testament to our spirit, certainly, but also a stark reminder that the universe grades on a very, very steep curve when it comes to hospitality. And Mars, bless its rusty, irradiated heart, is a D- student in that particular subject. Pleasant dreams of red deserts, under a sky where Earth is just another star. Leaving the dusty, ambitious, and frankly rather stressful plains of potential Martian colonization, our cosmic journey now brings us a little closer to home, though not without its own subtle undercurrent of existential unease. We're drifting towards an event scheduled for April 13, 2029. Mark your calendars or don't, it'll happen anyway. On this particular Friday the 13th, oh, the universe does enjoy its little ironies, doesn't it? An asteroid named 99942 Apophis will make an exceptionally close flyby of Earth. And when we say close, we mean cosmically close. Closer than many of our geostationary satellites. Close enough for a good long scientific stare. Apophis, named after the ancient Egyptian deity of chaos and destruction. Astronomers clearly have a flair for the dramatic, or perhaps just a wonderfully dark sense of humor, is a stony asteroid, roughly 335 meters, about 1,100 feet, across. Not a planet killer, not by a long shot, but certainly large enough to cause significant regional devastation if it were to impact. Imagine something the size of several city blocks, or perhaps a rather chunky sports stadium, deciding to pay an uninvited high-velocity visit. It would make for a very, very bad day for whatever region it chose to grace with its presence. Thankfully, the 2029 flyby is unequivocally not going to be an impact event. Let's get that clear. Science has run the numbers, checked them twice, and Apophis will sail on by, a silent, swift visitor in the night. Or rather, visible as a point of light moving across the sky, even to the naked eye from some parts of the world, particularly Europe, Africa, and Western Asia. This event, this close shave as some might dramatically call it, is a golden opportunity for science. It's like having a piece of the asteroid belt delivered to our doorstep for intensive study, without the messy crater and ensuing global panic. Scientists will be able to bounce radar signals off it with unprecedented detail, map its surface, study its composition, its spin, how it wobbles. They'll learn more about its internal structure and how the Earth's gravity tugs and flexes it during this close encounter. This information is invaluable, not just for understanding Apophis itself, but for understanding the broader population of near-Earth objects, or NEOs, that regularly cross our planet's orbital path. It's crucial data for planetary defense, that rather sobering field dedicated to figuring out how to nudge away any future cosmic bullies that might have Earth's name written on them. There's a certain majesty to this celestial mechanics, isn't there? The precise, gravitational dance of planets and asteroids, all governed by immutable physical laws. We can predict these encounters decades, even centuries in advance. Apophis was discovered in 2004, and for a brief, nail-biting period, there was a non-trivial, though still small, chance calculated for an impact in 2029, or subsequent encounters in 2036 or 2068. Further observations blessedly ruled those out. Phew. Collective sigh of relief from the astronomical community, and presumably anyone fond of continued existence. But the initial flutter of concern was a potent reminder of the cosmic shooting gallery we inhabit. Imagine lying there, feeling the gentle rhythm of your breath, and picturing this dark, silent rock born in the chaos of the early solar system, now hurtling through the void at tens of thousands of kilometers per hour, on a trajectory that will bring it breathtakingly close to our home world. It's a stark visual. It's a reminder of the fine print of living in a dynamic solar system. For every beautiful nebula, for every inspiring planetary vista, there are also these cosmic bullets. Most miss. Most are tiny, burning up harmlessly as meteors. But some are big enough to make us sit up and pay attention. Apophis is one of those. The beauty of this particular flyby in 2029 is its safety. It's all the awe, none of the, oh dear, we need to evacuate a continent. It's a chance to marvel at the universe's workings up close, to appreciate the power of science to predict and understand these events, and to gather knowledge that might one day be crucial for our survival. There's a reassurance in that, a sense that we are not entirely helpless driftwood in the cosmic ocean. We have telescopes, we have mathematics, we have increasingly clever ideas about how to deal with these potential threats. We are, at least, aware of the game of orbital roulette being played around us. Whether we're any good at playing it is another question entirely, one we'll touch upon. But for Apophis in 2029, it's a scientific gift. A moment to observe, to learn, to refine our models. And for us, drifting towards sleep, it's a chance to contemplate the vastness and the occasional near misses with a sense of calm detachment. The universe isn't trying to hit us. It's not personal. It's just physics. Immense, indifferent, and occasionally very, very close. Like that relative who always stands a bit too near when they're talking to you, invading your personal space, but in this case it's a 335-meter rock and personal space is defined in astronomical units. So, as it glides past, a silent shadow against the stars, let Apophis be a symbol not of fear, but of knowledge, of the intricate dance of gravity, and of our own growing awareness of the cosmic neighborhood. A visitor, indeed, one that reminds us of our place, our vulnerability, but also our capacity to understand and perhaps one day to protect ourselves. It's a beautiful, slightly unsettling lullaby, sung by the silent passage of a dark stone, reminding us that the heavens are not always serene, but they are always fascinating. And for 2029, fascinating without the immediate threat of obliteration, which is, a nice bonus. Enjoy the flyby from a safe, sleepy distance. We've just watched Apophis, our 335-meter chunk of cosmic rock, sail harmlessly by in 2029, a scientific gift rather than a harbinger of doom. This close encounter, however, naturally leads our drifting thoughts to a somewhat more pragmatic and perhaps slightly less relaxing consideration: planetary defense. It's a rather grand term, isn't it? Planetary defense. It conjures images of Earth shielded by gleaming energy fields, or brave astronauts flying off to blow up incoming asteroids, preferably with a stirring rock anthem playing in the background. The reality, as is often the case, is a little less Hollywood and a lot more, painstaking scientific and engineering work, often performed on budgets that wouldn't cover the catering for a single blockbuster disaster movie. The Apophis Flyby, while not a threat itself, is a crucial data point for this burgeoning field. Understanding how asteroids are built, how they respond to gravitational nudges, how their orbits evolve, this is all vital intelligence for the day when we might spot something larger, something with Earth's name definitively on its cosmic itinerary, and with less than a century's notice. Because let's be frank, while Apophis is a known quantity, well-tracked and understood, the solar system is a big, messy place. There are still undiscovered objects out there, lurking in the darkness, whose orbits might one day intersect ours in a rather inconvenient manner. It's the unknown unknowns that tend to keep planetary defense specialists up at night, metaphorically speaking. Or perhaps literally if they're pulling an all-nighter at a telescope. So, what does Earth's flimsy umbrella, as we might wryly call our current planetary defense capabilities, actually look like? It's primarily about finding them first. Surveys like Pan-STARRS, the Catalina Sky Survey, and upcoming behemoths like the Vera C. Rubin Observatory are designed to scan the skies, to catalog near-Earth objects, to calculate their orbits, and to flag any potential impactors. It's a monumental game of celestial hide-and-seek, played against a backdrop of infinite black. We've gotten pretty good at finding the really big ones, the civilization enders, a kilometer or more across. The good news? We don't think any of those are on a collision course for the foreseeable future. The less good news? There are many more smaller ones in the Apophis size range or a bit smaller, still capable of causing regional devastation, a very bad tsunami, or just generally ruining everyone's millennium, that are harder to spot and track. We're finding more all the time, but the catalog is far from complete. It's like trying to count all the mosquitoes in a swamp at night with a fairly dim flashlight. Once we find one that looks a bit iffy, what then? This is where the action part of planetary defense comes in, and where the solutions start to sound reassuringly like science fiction, albeit a rather more sober, peer-reviewed version. The leading contender for a well-understood threat, given enough warning time, years, ideally decades, is a kinetic impactor. Essentially, we build a spacecraft and we ram it into the asteroid. Not to blow it to smithereens, that's much harder than it looks in movies and could just create a deadly swarm of slightly smaller rocks, but to give it a tiny nudge to change its velocity by a minuscule amount. Over years, that tiny nudge translates into a significant change in its orbital path, causing it to miss Earth entirely. NASA's DART mission in 2022 was a spectacular proof of concept for this, successfully altering the orbit of the small asteroid Dimorphos. A cosmic billiard shot, if you will. Very neat. Very precise. Other ideas are on the drawing board, of course. Gravity tractors, parking a massive spacecraft nearby and letting its gentle gravitational pull slowly tug the asteroid off course. Laser ablation, blasting the asteroid's surface with powerful lasers to vaporize rock, creating thrust. And yes, in truly desperate last-minute scenarios, the nuclear option is sometimes whispered about, though it comes with a host of terrifying complications and the distinct possibility of making things much worse if not done perfectly. It's generally considered the option you use when all other, more elegant options have failed and you're staring down the barrel of an extinction-level event. Let's hope we never have to dust off that particular emergency plan. But here's the cosmic chuckle, the little piece of gallows humor to accompany your descent into sleep. Our planetary defense systems, valiant and clever as they are designed for the threats we can anticipate, the ones that play by the known rules of orbital mechanics. What about the truly big cosmic bullets? The rogue interstellar comets, appearing from the deep darkness with little warning, moving at incredible speeds? What about an unexpected, catastrophic asteroid fragmentation event nearby? Our current umbrella, while offering some protection from the predictable drizzle, might not fare so well against a sudden, unforeseen cosmic typhoon. It's the difference between having a good smoke detector and living next to a dynamite factory run by particularly careless clowns. There's a profound humility in this, isn't there? We strive, we innovate, we build our clever little defenses. And the universe, in its vast, silent majesty, holds energies and objects that could swat our best efforts aside like a bothersome fly. It's not to say planetary defense isn't worthwhile. It absolutely is. It's a rational, responsible step for a species that has achieved the technological capability to take it. But it's also important to maintain a sense of cosmic perspective. We are learning to dodge some of the smaller celestial hailstones, but we still live in a galaxy where supernovas explode, where gamma-ray bursts could sterilize entire sectors, where things far beyond our current comprehension or control occur. So, as you drift, feel a sense of quiet appreciation for the scientists and engineers working to keep our little blue marble safe from the more common cosmic potshots. They are the unsung heroes, the diligent watchers of the night sky. But also, allow yourself a wry, sleepy smile at the sheer scale of it all. Our umbrella is getting better, but the universe can conjure some truly epic storms. And in that vastness, in that slight precariousness, there's a strange kind of peace. A letting go of the illusion of complete control. We do what we can. And for the rest, well, that's what cosmic bedtime stories are for. To contemplate the immensity and then to gently, peacefully fall asleep under the vast, starry, and occasionally hazardous sky. Having contemplated the rather unsettling yet reassuringly proactive world of planetary defense, let our minds drift outwards again, further into the cosmic ocean, carried on the gentle currents of future discovery. We're moving beyond the immediate concerns of our solar system's occasionally wayward rocks, and into the realm of truly profound cosmic questions. The next 100 years promise not just new missions within our stellar neighborhood, but also new eyes on the universe itself, the launch of next-generation space telescopes, successors to the already legendary James Webb Space Telescope, JWST, and its predecessors. Imagine, if you will, even more powerful windows opening onto the cosmos, allowing us to peer deeper into space and further back in time than ever before. The JWST, even in its early years, has already revolutionized astronomy, unveiling breathtaking images of the early universe, the birth of stars, and the atmospheres of distant exoplanets. But science, bless its insatiable curiosity, is never content. Even as Webb delivers its wonders, astronomers and engineers are already dreaming, planning, and designing what comes next. Telescopes that might dwarf Webb in size, or operate at different wavelengths, or employ entirely novel technologies to capture the faint whispers of light from the universe's dawn, or from worlds orbiting other stars. It's like giving a master painter an even finer brush, an even richer palette of colors. The masterpieces they could create are almost beyond our current imagining. Think about the questions these future eyes might help us answer. We could witness the formation of the very first galaxies with even greater clarity, seeing those initial sparks of structure coalesce in the primordial darkness. We could probe the epoch of reionization, when the first stars and quasars burned off the cosmic fog of neutral hydrogen that filled the early universe, in exquisite detail, understanding how the cosmos became transparent as it is today. It's like trying to read the universe's baby book, deciphering the earliest, faintest entries. A rather grand and dusty tome, that one. And then there's the search for life beyond Earth. This is where these future telescopes truly ignite the imagination, and perhaps, a little frisson of existential anticipation. They will be designed with the capability to analyze the atmospheres of exoplanets, planets orbiting other stars, with unprecedented precision. They'll be hunting for biosignatures, chemical clues that might hint at the presence of life. Things like oxygen, methane, ozone, in combinations that are difficult to explain through purely geological or chemical processes. Imagine pointing a colossal telescope at a tiny point of light, a distant sun, and teasing out the subtle chemical fingerprint of its orbiting worlds, looking for that telltale sign that something, or someone, is breathing over there. It gives you a slight shiver, doesn't it? In a good way, mostly. The sheer number of exoplanets we've already discovered is staggering, thousands confirmed, with countless more awaiting detection. Our Milky Way galaxy alone likely teems with hundreds of billions of planets. It seems statistically improbable, almost perverse, for Earth to be the only one with life. But improbable and impossible are two very different things in the cosmic dictionary. These future telescopes will move us beyond mere statistical arguments and into the realm of potential observation. They might provide the first tentative, tantalizing evidence that we are not alone. Or equally profoundly, they might deepen the silence, finding world after world that is sterile, barren, or just chemically uninteresting from a biological perspective. There's a quiet grandeur in this quest. It's humanity holding a cosmic stethoscope to the chest of the universe, listening for a heartbeat. The patience required is immense. The data analysis will be painstaking. A positive detection of a biosignature wouldn't be a flashing neon sign saying, "Aliens here." It would likely be a subtle anomaly in a spectrographic chart, debated, reanalyzed, checked for false positives from a dozen different angles, before any cautious announcements are made. Science, at its best, is a deeply skeptical optimist. But what if they find something? What if, within the next 100 years, one of these magnificent future eyes locks onto a distant exoplanet and finds compelling evidence of biological processes? The philosophical implications are, well, monumental. It would reshape our understanding of our place in the universe more profoundly than anything since Copernicus and Galileo nudged humanity from the center of creation. It would mean that life, this strange, complex, self-replicating phenomenon, is not a unique fluke confined to our little blue pebble, but potentially a common cosmic occurrence. A comforting thought for some, perhaps a deeply unsettling one for others who prefer their universe tidy and human-centric. And what if they find nothing? What if, after decades of searching, after scrutinizing thousands of potentially habitable worlds with ever more powerful instruments, the silence remains unbroken? That too would be a profound discovery. It might suggest that the conditions for life, or at least for life detectable by us, are far rarer than we currently imagine. It could lend weight to the rare Earth hypothesis, the idea that our planet, with its specific geology, its large moon, its protective magnetic field, its plate tectonics, is an extraordinary cosmic anomaly. The silence could be just as telling as a signal. It might make us cherish this fragile biosphere all the more, knowing it's an even rarer jewel than we thought. Or it might just mean we're not looking in the right way or for the right things. The universe is under no obligation to make its secrets easily discoverable by primates who've only just figured out how to send radio waves. So, as you drift deeper, imagine these great observatories of the future, silent sentinels in the cold of space, their mirrors focused on impossibly distant targets. They are extensions of our own eyes, our own curiosity, our own yearning to understand. They represent hope, the relentless human drive to know. But they also represent a confrontation with the unknown, and the possibility that the answers we find might not be the ones we expect or even desire. They might reveal a universe teeming with life, or one echoing with a profound cosmic loneliness. Either way, the view will be spectacular. And the journey to find out, a grand, sleepy adventure into the heart of the unknown. Our silent, drifting journey continues, lingering on the promise of those magnificent future telescopes. We've imagined them peering into the dawn of time, scrutinizing the atmospheres of distant exoplanets. And this inevitably brings us to the very heart of one of humanity's oldest, most persistent questions. Are we alone? The hunt for biosignatures, those subtle chemical hints of life, is a primary goal. But let's, just for a moment as you nestle deeper into your pillows, consider the implications. We're not just hunting for alien microbes, as fascinating as that would be. The unspoken, perhaps even slightly feared, hope is for something more. Something that might eventually look back. And this is where the hunt for someone else's problems, as we might cynically but not entirely inaccurately call it, truly begins. Imagine the moment. That subtle anomaly in the spectrographic data from a distant, Earth-like exoplanet resolves itself. It's not just oxygen. It's oxygen in combination with methane, in proportions that scream biology. And not just any biology, but perhaps complex, atmospheric-altering life. The scientific papers are published, cautiously at first, then with growing confidence. The world buzzes. For the first time, we have credible, albeit indirect, evidence of life beyond Earth. It's a profound shift. The universe suddenly feels a little less empty, a little more populated. But what kind of life? Simple, single-celled organisms happily munching on alien minerals and exhaling convenient biosignatures? That's the safest bet and frankly the one most astrobiologists expect, if anything. Slime is probably far more common than starship captains. And finding alien slime would still be revolutionary. It would mean the spark of life can ignite elsewhere, that biology is not a terrestrial monopoly. A wonderfully comforting and scientifically thrilling discovery. We could all sleep a little easier knowing that life in some form is a cosmic phenomenon. Or could we? Because the moment we confirm any life elsewhere, the next question immediately follows. Is there intelligent life? Is there anyone out there capable of building their own telescopes, of pondering their own existence, of perhaps noticing us? This is where the comforting warmth of finding alien microbes can quickly morph into a more unsettling chill. Stephen Hawking, among others, famously cautioned against actively trying to contact extraterrestrial civilizations, suggesting that if they are advanced enough to reach us, their intentions might not be entirely benign. He likened it to Native Americans encountering Columbus, an encounter that, from the Native American perspective, didn't end particularly well. A rather stark, but perhaps not entirely unwarranted, analogy. The someone else's problems aspect comes into sharp focus here. If we detect biosignatures, it's one thing. If we were to detect technosignatures, evidence of alien technology like industrial pollution in an atmosphere or strange radio signals, or vast astroengineering projects, that's a whole different kettle of cosmic fish. Suddenly, we're not just dealing with the abstract concept of life, but with a civilization. And civilizations, as our own history amply demonstrates, come with baggage. They have needs, resources, ideologies, and potentially very advanced weaponry or an insatiable hunger for cosmic real estate. Or perhaps they're just incredibly messy neighbors who leave their space junk scattered all over the galactic lawn. Consider the Great Filter Theory. It posits that there might be some evolutionary or technological hurdle so immense that it prevents most life from reaching an advanced spacefaring stage. If we find simple life is common, but intelligent life is nowhere to be seen, it might mean the Great Filter is still ahead of us. Some catastrophic event or self-inflicted doom that awaits all aspiring civilizations. A rather sobering thought to accompany your drift into slumber. Finding only alien algae might, paradoxically, be bad news for our own long-term prospects. Hooray slime. Oh wait, does that mean we're doomed to become cosmic fertilizer too? And what if we do find evidence of a technological civilization? What if those future telescopes or dedicated SETI, search for extraterrestrial intelligence, programs, pick up an unambiguous signal? The sheer, world-shattering impact of that discovery is almost impossible to overstate. Religions, philosophies, our entire sense of self and human uniqueness would be thrown into an existential blender. It would be the biggest news story in human history and potentially the most terrifying. Because then comes the what next? Do we reply? Do we hide? Do we send a strongly worded letter asking them to keep their Dyson sphere emissions down? The unsettling implications of extraterrestrial life are not just the stuff of cheap science fiction. They are genuine, albeit highly speculative, concerns that philosophers and scientists ponder. Would they be peaceful explorers or ruthless colonizers? Would their biology be so alien we couldn't even recognize them as alive, or worse, accidentally offend them by, say, admiring their primary organ of respiration? Would their understanding of the universe be so far beyond ours that any attempt at communication would be like an ant trying to discuss quantum physics with a human? The potential for cosmic misunderstanding is vast. Sure, finding aliens would be cool. Until they show up and realize we're the cosmic equivalent of noisy, self-destructive toddlers. Then it's less, welcome to Earth, and more, please don't vaporize our oceans because you find our reality TV offensive. So, as you allow your mind to gently float amongst these possibilities, acknowledge the profound dual nature of this search. It's born of our deepest curiosity, our yearning for connection, our desire to know our place. But it also carries the faint, unsettling scent of the unknown, the potentially hazardous. The universe, in its infinite variety, could hold wonders beyond our wildest dreams, or horrors beyond our most creative nightmares. Or, most likely, something far stranger and more indifferent than either. For now, the hunt for those biosignatures, those faint whispers of otherness, is a gentle, sleepy quest. A quest for someone else's problems, perhaps. Or maybe, just maybe, for someone else who's also lying awake, staring at their own night sky and wondering if they too are alone. A strangely comforting thought, that potential shared cosmic insomnia. From the profound, potentially unsettling search for extraterrestrial life, our cosmic journey through the next century now veers towards something a little more commercial. A little more relatable, perhaps, to our everyday aspirations, albeit scaled up to an orbital level. We're talking about the dawn of true commercial space tourism. Orbital hotels, lunar trips for civilians with sufficiently deep pockets, one presumes. The common dream of flying into space, of seeing that iconic, breathtaking curve of the Earth from above, might actually become an attainable, if eye-wateringly expensive, reality for more than just a handful of government-trained astronauts. You can almost see the glossy brochures now, can't you? Experience the ultimate getaway. Zero-gravity spas. Unparalleled views of the home planet. Moon rock collecting excursions, BYO tiny chisel and very sturdy Ziploc bag. It all sounds wonderfully glamorous, doesn't it? A chance to float effortlessly, to gaze upon the majestic tapestry of Earth unfurled below, the swirling clouds, the continents outlined against the deep blue oceans, the delicate, shimmering ribbon of the atmosphere. It's an experience universally described by astronauts as life-changing, perspective-altering. The overview effect, they call it, that profound cognitive shift, that sense of unity and the fragility of our planet, that comes from seeing it as a tiny, precious jewel suspended in the vast black velvet of space. And who wouldn't want a piece of that? To escape the mundane, the terrestrial, the relentless pull of gravity for a few days, a week perhaps. To sip a recycled water cocktail while watching 16 sunrises and sunsets a day from your orbital hotel window. The allure is undeniable. Humanity has always been drawn to frontiers, to novel experiences, to bragging rights. And I spent my summer vacation in low Earth orbit is a pretty potent bragging right. It certainly beats, I went to that slightly disappointing timeshare in Florida again. But as you continue your gentle drift towards slumber, let's pull back the curtain on this glamorous vision just a little. Let's inject our signature dose of wry realism into the fantasy of the ultimate luxury vacation. Because space, while undeniably beautiful from a distance, is also, as we've established, a fundamentally hostile environment. And transforming it into a comfortable, safe, and affordable tourist destination presents some, shall we say, interesting challenges. Space tourism, the ultimate discomfort zone, potentially masquerading as the ultimate luxury. First, there's the getting there. Rocket launches, while becoming more routine, are still fundamentally controlled explosions. You're strapping yourself to a giant metal tube filled with highly volatile propellants and hoping for the best. It's not quite like boarding a slightly delayed budget airline flight where the worst you might encounter is a crying baby and a distinct lack of legroom. The G-forces, the vibrations, the sheer raw power involved in escaping Earth's gravity, it's an intense experience, not for the faint of heart or those prone to motion sickness on a truly epic scale. Your in-flight meal might be the least of your worries if it's trying to escape your stomach at Mach 3. Then once you're up there in your swanky orbital hotel, what's it really like? Forget spacious suites with panoramic windows you can throw open for a bit of fresh, non-existent air. Think more along the lines of a very expensive, very high-tech submarine. Space is at a premium. Every kilogram launched into orbit costs a fortune. So your luxury cabin might be more akin to a cozy, cramped pod with meticulously engineered life support humming constantly in the background, a gentle reminder that a thin metal wall is all that separates you from instant, explosive decompression. Relaxing. And the effortless floating? Zero gravity is fun for a while. The novelty of chasing your rehydrated shrimp cocktail around the cabin, the ability to do somersaults without bumping into the coffee table. But it also plays havoc with the human body. Space adaptation syndrome, essentially space sickness, is common, bringing nausea and disorientation. Fluids shift to your head, giving you a puffy face and a permanent head cold. Muscles and bones begin to atrophy without the constant stress of gravity. So your relaxing float might involve a strict exercise regimen to stop your body from slowly disintegrating. Just what you want on vacation. Mandatory treadmill time while tethered to a wall. Let's not forget the radiation we discussed earlier. While orbital hotels will undoubtedly be shielded, you're still getting a higher dose than you would on Earth. Not enough to cause immediate problems for a short trip, but perhaps something to consider if you're planning on becoming a frequent flyer. And the view, while undeniably spectacular, is also constant. 16 sunrises and sunsets a day can play merry hell with your circadian rhythms. You might need a very good eye mask and an even better understanding of your body clock, which will likely be screaming, "What in the celestial mechanics is going on?" And the food? While it will undoubtedly be an improvement on the early Apollo paste-in-a-tube cuisine, preparing and eating food in zero gravity has its own unique set of challenges. Crumbs don't fall, they float, potentially into sensitive equipment. Liquids form spheres and need to be sipped from sealed pouches. That romantic candle at dinner for two overlooking the Earth? Probably not going to happen unless you enjoy chasing rogue peas with a pair of tweezers and have a fire suppression system that can handle flaming wax globules in microgravity. It's more likely to be carefully managed, nutrient-dense paste, consumed with the quiet dignity of someone who has paid a fortune for the privilege of eating said paste in a very unusual location. So, yes, the dream of commercial space tourism is exciting. It represents a democratization of space access, a new frontier for human experience. But let's approach it with our eyes open and perhaps a wry smile. It will be an adventure, undoubtedly. It will be exclusive, certainly. But relaxing, in the traditional fluffy slippers in a good book sense? Perhaps not initially. It will be the ultimate adventure trip, the ultimate status symbol, and quite possibly, the ultimate way to realize just how incredibly comfortable and accommodating our own planet Earth actually is. Maybe the true luxury of space tourism will be the profound appreciation you feel for a simple, gravity-bound, oxygen-rich walk in the park when you get back. A very expensive way to appreciate the free things in life. Sweet dreams of floating, and the blessed relief of eventually perhaps not floating. Our cosmic voyage, having briefly dallied with the somewhat questionable comforts of orbital hotels, now propels us further out, into the colder, darker, and infinitely more mysterious realms of the outer solar system. We leave behind the relatively, and I use that term loosely, familiar notion of human travel and delve into the robotic exploration of some of the most tantalizing and enigmatic destinations our celestial neighborhood has to offer, the ocean moons. Worlds like Jupiter's moon Europa, and Saturn's moons Enceladus and Titan. These aren't just barren, cratered rocks. Oh no. These are worlds that whisper of hidden depths, of vast, subsurface oceans of liquid water, concealed beneath thick shells of ice. And where there's water, as the astrobiological mantra goes, there's the potential for life. It's a captivating, almost romantic idea, isn't it? These icy moons, orbiting giant, distant planets, far from the sun's habitable zone as we traditionally understand it. Yet, beneath their frozen crusts, warmed by the tidal forces exerted by their colossal parent planets and the decay of radioactive elements in their cores, could lie the largest oceans in our solar system. Vast, dark, and utterly alien seas, perhaps miles deep, that have remained liquid for billions of years. The mystery of these hidden water worlds is a powerful lure, a siren song for robotic probes and the scientists who designed them. Imagine Europa. Its surface is a crazy quilt of fractured ice, crisscrossed with reddish-brown cracks and ridges, hinting at the dynamic ocean stirring beneath. This isn't a static, frozen wasteland. It's a geologically active world, where plumes of water vapor have possibly been seen erupting from its southern polar regions, like icy geysers, venting material from that hidden ocean directly into space. A tantalizing glimpse of what lies beneath, a sort of free sample for any passing spacecraft nimble enough to fly through it. Future missions are being designed with exactly this in mind, to swoop through these plumes, to analyze their composition, to search for those telltale biosignatures we discussed earlier, but this time in material sourced directly from a potentially habitable environment. Then there's Enceladus, a tiny, sparkling moon of Saturn, which is even more overt in its aquatic generosity. The Cassini spacecraft discovered astonishing plumes of water ice, organic compounds, and even salt erupting from tiger stripes, warm fractures, near its south pole. These plumes feed Saturn's E-ring. Enceladus is, quite literally, spraying its ocean into space for us to study. It's like the universe has set up a convenient drive-through for astrobiologists. Yes, I'll take one sample of subsurface ocean with a side of complex organics, please. The sheer audacity of it is breathtaking. Here, deep in the cold outer reaches, is a small moon with a liquid water ocean, energy sources from tidal heating and organic molecules, all the basic ingredients for life as we know it. And Titan, Saturn's largest moon, is a different beast altogether, yet equally fascinating. It has a thick, nitrogen-rich atmosphere, eerily similar to early Earth's. It has rivers, lakes, and seas, but not of water. On Titan's frigid surface, methane and ethane play the role of water, carving channels, falling as rain, pooling in vast, dark expanses. But beneath this bizarre hydrocarbon surface, evidence suggests Titan, too, may harbor a subsurface ocean of liquid water, perhaps mixed with ammonia, acting as an antifreeze. An ocean within an ocean world, a truly alien Matryoshka doll of hydrological possibilities. The hope of finding life in unexpected places is palpable when we consider these ocean moons. If life can arise and thrive in these dark, cold, high-pressure environments, shielded from sunlight but sustained by chemical energy welling up from the moon's interior, much like life around hydrothermal vents on Earth's ocean floors, then it radically expands our definition of habitable. It would mean that the conditions for life are not confined to the narrow Goldilocks zones, around stars where liquid water can exist on a planet's surface. Life could be lurking in the hidden depths of countless icy worlds across the galaxy. The universe could be far more squishy and biologically interesting than we previously dared to imagine. But let's, as we drift in these watery, subglacial dreams, also consider the sheer, crushing reality of these environments. Life's hidden, chilly sanctuaries they might be, but they are also realms of unimaginable pressure, absolute darkness, and profound isolation. Any life there would be utterly alien to us, adapted to conditions that would instantly kill any terrestrial organism. Imagine trying to explore these oceans. Forget scuba diving. You'd need incredibly robust robotic submersibles, capable of withstanding pressures hundreds or even thousands of times greater than at sea level on Earth, navigating in perpetual blackness, perhaps through water thick with unknown chemicals. It's a technological challenge of the highest order. And what if we do find life? Microbes most likely. But what kind? Based on chemosynthesis rather than photosynthesis? With a completely different biochemistry? The thrill of discovery would be immense. But so too would be the responsibility. The prime directive of Star Trek fame, not interfering with the development of alien life, would become a very real ethical consideration. How do we explore without contaminating? How do we study without destroying? These are not just scientific questions but deep philosophical ones. We might be peering into a pristine billion-year-old ecosystem, and our first clumsy robotic touch could irrevocably alter it. A sobering thought for any would-be interplanetary marine biologist. So, as you sink deeper into your peaceful state, let the image of these ocean moons fill your mind. Icy shells concealing vast, dark, secret seas. The potential for life, clinging to existence in the most unexpected of cosmic corners. It's a testament to the universe's capacity for surprise, for harboring beauty and complexity in the most unlikely of places. The search for life in these hidden depths is a slow, patient game, one that will unfold over decades, with missions launching in the coming years and throughout the next century. It's a journey into the unknown, a dive into the cosmic abyss, hoping to find a glimmer of life staring back from the cold, dark, watery depths. A profoundly hopeful and profoundly humbling quest. Sleep now and perhaps dream of silent, starlit oceans hidden far away. Having plunged into the speculative, watery depths of distant ocean moons, let's allow our cosmic current to draw us back a little closer to home, to phenomena more readily observable, more directly connecting us to the celestial sphere from our own terrestrial vantage point. We turn our sleepy gaze towards the more predictable, yet no less beautiful, cosmic events. Special total solar and lunar eclipses and rare planetary alignments. These are the universe's own theatrical performances, staged in our skies, offering moments of breathtaking beauty and a tangible sense of our place within the solar system's grand clockwork mechanism. Over the next 100 years, Earth will continue its stately waltz around the sun, and the moon its more intimate, looping dance around Earth. And from time to time, these dancers will align in just the right way to create spectacles that have captivated humanity for millennia. Total solar eclipses, when the moon passes directly between the sun and Earth, casting its dark umbral shadow upon a narrow path across our planet's surface, are perhaps the most dramatic of these. For a few precious, fleeting minutes, daylight turns to an eerie twilight. The sun's brilliant disk is completely obscured, revealing the ethereal, pearly glow of its corona, its superheated outer atmosphere, a sight normally hidden by the sun's own dazzling glare. Stars and planets can become visible in the daytime sky. The temperature drops. An unnatural stillness can fall. It's a profoundly moving, almost primal experience. Imagine standing in that path of totality. One moment, bright sunshine. The next, a creeping darkness, as if a giant celestial hand is dimming the world. And then totality. The sun transformed into a black hole surrounded by a ghostly halo. It's easy to see why ancient cultures often viewed these events with awe and trepidation, inventing myths of celestial dragons devouring the sun. Even now, with our scientific understanding of orbital mechanics, there's a sense of the sublime, of witnessing something truly extraordinary, something that connects you directly to the cosmic scale of things. These events are meticulously predicted, of course. Eclipse chasers, modern-day pilgrims of the shadow, plan their travels years in advance to stand in the right place at the right time. The next century will offer its share of these celestial appointments across various parts of the globe, each one a fleeting moment of shared wonder. Then there are total lunar eclipses. Less rare, perhaps, and visible from a much wider area, but no less beautiful in their own way. This occurs when the Earth passes directly between the sun and moon, casting its own shadow onto the lunar surface. The moon doesn't usually disappear completely, but instead, it often glows a dim, coppery red, the famed blood moon. This ruddy hue is caused by sunlight filtering through Earth's atmosphere, with the blue light scattered away, allowing the red light to pass through and illuminate the shadowed moon. It's like all the sunrises and sunsets of Earth are being projected onto the lunar face. A gentle, subtle beauty, a reminder of our own planet's atmospheric veil. And beyond eclipses, there are the planetary alignments or conjunctions. These occur when two or more planets appear very close together in our night sky from our perspective on Earth. They aren't physically close in space, of course, often millions of kilometers separate them. But from our vantage point, they can create striking celestial groupings. A bright Venus sidling up to Jupiter, perhaps with a slender crescent moon nearby. Saturn and Mars appearing as close companions. These celestial dances, as they're often called, are more frequent than total eclipses, but some alignments are rarer and more visually spectacular than others. They add a dynamic element to the familiar patterns of the constellations, a sense of planets on the move, tracing their ancient paths across the ecliptic. There's a deep comfort in these predictable celestial rhythms. In a universe that can often feel chaotic and overwhelmingly vast, these events offer a sense of order, of mathematical precision. They are moments when the intricate geometry of the solar system becomes directly visually apparent. They are also moments of shared human experience. When a total solar eclipse sweeps across a populated area, or a particularly beautiful planetary conjunction graces the evening sky, millions look up. Strangers share telescope views, point out celestial wonders to each other. For a brief time, our terrestrial squabbles and anxieties can fade into the background, replaced by a collective sense of awe. These are magical moments in the night sky, not in a supernatural sense, but in their ability to evoke wonder and a sense of connection. They are a direct, visceral link to the cosmos. You don't need a PhD in astrophysics to appreciate the stark beauty of the solar corona or the gentle glow of a blood moon. You just need to look up. And in that simple act of looking up, of witnessing these ancient, recurring celestial plays, there's a profound sense of peace, of belonging to something much, much larger than ourselves. These are the universe's free shows, gentle reminders of its grandeur, its beauty, and its exquisite, predictable order, at least in our local neighborhood. As you drift deeper into sleep, perhaps you can imagine one of these celestial ballets unfolding above you, a silent, beautiful performance just for you, a lullaby written in light and shadow across the vast canvas of the night. These fleeting shows are a brief respite, a reminder of the beauty that endures cycle after cycle. We've just been marveling at the predictable beauty of celestial dances, the eclipses, the planetary alignments, those moments when the solar system's clockwork seems to perform just for us. There's a comfort in that predictability, a sense of order that can be deeply soothing as you drift towards sleep. But now, let's gently, ever so gently nudge that comforting thought with a touch of our signature cosmic realism. Because while these events are undeniably beautiful and awe-inspiring to us, it's crucial to remember the grand indifference of the cosmic choreography itself. These celestial alignments are just physics, dear listener. Just gravity doing its inexorable, elegant, and entirely impersonal thing. The moon doesn't intentionally align itself to create a breathtaking solar eclipse for humanity's viewing pleasure. It simply follows its orbit, an orbit dictated by the gravitational interplay between Earth and Sunday. That its apparent size in our sky so perfectly matches the apparent size of the distant sun is a remarkable coincidence, a beautiful accident of cosmic geometry from our particular vantage point. But it's an accident nonetheless. If the moon were slightly smaller or orbited slightly further away, total solar eclipses wouldn't happen. If it were larger or closer, they'd be more common, perhaps less special. The universe isn't tailoring its stagecraft for our aesthetic enjoyment. We are simply fortunate enough to be living on a planet where the celestial mechanics occasionally produce results that our pattern-seeking brains find deeply beautiful and meaningful. Similarly, when planets appear to align in our night sky, forming those lovely conjunctions, they aren't gathering for a cosmic committee meeting or putting on a deliberate show for terrestrial skywatchers. They are vast, independent worlds, each pursuing its own solitary path around the sun, separated by unimaginable gulfs of cold, empty space. Their apparent closeness is purely a line-of-sight effect, a temporary configuration from our specific tiny viewpoint in the vastness. Venus doesn't care that it's passing Jupiter. Mars isn't aware that Saturn is its temporary celestial neighbor. They are simply moving as they have for billions of years, governed by the same gravitational laws that hold our galaxy together, that dictate the fall of an apple, that keep your feet gently pressed against your bed. This grand indifference isn't meant to diminish the beauty or the wonder we feel when witnessing these events. Not at all. In fact, for some, it can enhance it. It highlights the extraordinary nature of our own consciousness, our ability to perceive this beauty, to find meaning and pattern in a universe that, by all evidence, operates without inherent purpose or intent for our benefit. The awe we feel is a product of our minds, our capacity for appreciation, our evolutionary wiring that finds patterns and significance. The universe provides the raw material, the light, the orbits, the vastness, and we, the observers, provide the interpretation, the emotion, the poetry. It's a collaboration of sorts, but a rather one-sided one. The universe supplies the canvas and the paint, and we get to call it art. The universe, meanwhile, is probably just wondering why that small, noisy planet in the suburbs of the Milky Way keeps staring so intently. There's a certain freedom in recognizing this indifference, isn't there? It means we don't have to worry about whether we're correctly interpreting the cosmic signs, or whether we're living up to some grand cosmic expectation. The universe isn't judging our eclipse photography skills or our odes to planetary conjunctions. It simply is. And its events unfold with a majestic, unthinking regularity. Your mortgage payment, your career anxieties, your existential angst about the meaning of it all, these are profoundly human concerns that have absolutely no bearing on the tilt of Saturn's rings or the timing of the next lunar eclipse. The celestial spheres will continue their silent, gravitational waltz regardless of the dramas unfolding on our little blue stage. This isn't to say that these events have no meaning. They have the meaning we assign to them. They are opportunities for connection, with the cosmos, with each other, with the history of humanity that has looked up at these same skies for millennia. They are moments that can inspire art, science, philosophy. They can jolt us out of our mundane routines and remind us of the larger context of our existence. But that meaning is a human creation, a testament to our remarkable minds, not an inherent property of the photons striking our retinas. It's a subtle but important distinction, one that can, paradoxically, deepen our appreciation while simultaneously grounding us in a more realistic understanding of our place. So, as you lie there, feeling the gentle pull of sleep, picture those celestial ballets. The moon sliding across the sun, Earth's shadow caressing the moon, planets drawing near in the twilight sky. Appreciate their beauty, their silent grandeur. And at the same time, hold the thought that this intricate dance is entirely unintentional, a byproduct of gravitational laws playing out on a vast scale. The universe isn't putting on a show for you, but you, in your brief, conscious moment, have the extraordinary privilege of watching it anyway, and finding it beautiful. That, in itself, is a kind of magic born not of cosmic intent, but of human perception. A quiet, profound, and ultimately very sleepy thought. The universe doesn't care if you find meaning in its movements, but it doesn't stop you from doing so either. It's rather accommodating in its own indifferent way. Our cosmic journey through the anticipated highlights of the next 100 years is beginning to draw towards its gentle conclusion. We've touched upon returning comets, ambitious planetary expeditions, near-miss asteroids, powerful new telescopes, the tantalizing search for life, the dawn of space tourism, and the predictable beauty of celestial alignments. It's quite a celestial buffet, promising a century rich in discovery and undoubtedly new questions. For even as our knowledge expands, as our technology allows us to peer deeper and travel further, the universe has a remarkable habit of revealing ever more profound mysteries. The century's horizon, much like the cosmic horizon itself, is likely to be characterized by more questions than answers, especially when it comes to the really big, truly baffling stuff. Consider dark matter, for instance. This enigmatic substance, 5 times more abundant than all the ordinary matter, the stuff that makes up stars, planets, and us, remains stubbornly anonymous. We know it's there. Its gravitational influence is undeniable, shaping the rotation of galaxies, bending the light from distant objects, holding galaxy clusters together. Without dark matter, galaxies as we know them would fly apart. The large-scale structure of the universe wouldn't make sense. We can map its presence, infer its properties. It doesn't interact with light, hence dark, and it doesn't seem to clump together like ordinary matter. But what is it? Is it composed of exotic, undiscovered particles, WIMPs, weakly interacting massive particles, axions, sterile neutrinos? Or is our understanding of gravity itself incomplete on cosmic scales? Despite decades of searching, with incredibly sensitive detectors buried deep underground to shield them from cosmic rays, and with powerful particle colliders smashing atoms together in hopes of creating a fleeting dark matter particle, we've found, well, nothing definitive. Zilch. Nada. It's one of the most profound embarrassments and therefore one of the most exciting challenges in modern physics. The next generation of experiments, both terrestrial and space-based, will continue this hunt. Future telescopes might reveal more subtle gravitational lensing effects that could constrain its properties. But will we solve dark matter within the next 100 years? It's a tall order. It might remain one of those grand mysteries that eludes us, a shadowy cosmic scaffold whose nature we can only guess at, like trying to understand the architecture of a vast, invisible cathedral by observing how the dust settles around its unseen pillars. Comforting, isn't it? Most of the universe is made of stuff we can't see and don't understand. Makes you feel significant. And then there's its even more mysterious cousin, dark energy. This is the stuff, or perhaps the property of space-time itself, that is causing the expansion of the universe to accelerate. Not just expand, but expand faster and faster. This discovery, which earned a Nobel Prize, was a profound shock. We expected gravity to be slowing the expansion down. Instead, some kind of anti-gravity, some pervasive, repulsive force, is winning the cosmic tug-of-war. Dark energy constitutes roughly 70% of the total energy density of the universe. So, between dark matter and dark energy, about 95% of the cosmos is made of, we don't know what. We, with all our accumulated knowledge, all our powerful instruments, all our brilliant theories, are essentially clueless about the fundamental composition of the vast majority of reality. It's a humbling thought, perfect for lulling one into a state of profound, accepting ignorance. Future telescopes like the Euclid mission and the Vera C. Rubin Observatory are designed to map the distribution of galaxies and the history of cosmic expansion with unprecedented precision. This data will help refine our models of dark energy to see if it's a constant, the cosmological constant Einstein once called his biggest blunder, which might turn out to be not so blunderous after all, or if it changes over time. But understanding its fundamental nature, why it has the value it does, that's a question that might well transcend the next century, perhaps remaining a puzzle for civilizations far more advanced than our own, assuming any are out there and they haven't been baffled into catatonia by it. These are just two of the known unknowns. What about the unknown unknowns, the things we don't even know we don't know? The universe has a knack for throwing curveballs. Every time we think we're getting a handle on things, a new observation, a new anomaly opens up entirely new avenues of bewilderment. The nature of black hole singularities, the ultimate fate of the universe, will it end in a big rip, a big freeze, or a big crunch? The possibility of extra dimensions, the true meaning of quantum mechanics, these are questions that tickle the edges of our comprehension and will likely continue to do so for generations. So, as you drift on the cusp of sleep, let this sense of enduring mystery be a comfort, not a frustration. The universe is not a puzzle to be solved in a tidy, finite way. It's an infinite tapestry of unfolding wonders and complexities. The next 100 years will undoubtedly bring breathtaking discoveries, moments of clarity, and new technologies that allow us to probe deeper. But they will also, almost certainly, unveil new layers of mystery, new questions that we can't even formulate today. And that's the beauty of it. The quest for knowledge is endless. The horizon always recedes. It's a journey, not a destination. And on that endless, sleepy journey, there is always something new to wonder about, something new to be gently, cosmically perplexed by. The universe is under no obligation to make sense, especially not before bedtime. And so, our gentle, century-spanning cosmic drift is nearing its final moments for tonight. We've journeyed from the anticipated return of a familiar comet to the audacious human endeavors on Mars, skirted past a notable asteroid, peered through the lenses of future telescopes into the deepest recesses of space and time, pondered the existence of other life and the peculiar allure of orbital vacations, explored hidden ocean moons, and admired the clockwork beauty of eclipses and alignments. We've also acknowledged the profound and perhaps permanently humbling mysteries like dark matter and dark energy that will likely continue to baffle and inspire us. We are, in essence, closing the cosmic calendar on these next 100 years, at least for now, in our sleepy imaginations. What have we seen? A tapestry woven with threads of brilliant human ingenuity and threads of stark cosmic indifference. We've seen our relentless desire to explore, to understand, to push boundaries, set against a backdrop of a universe that is often unforgiving, frequently dangerous, and almost always operating on scales of time and space that dwarf our fleeting concerns into near insignificance. And yet, within that juxtaposition, there's a peculiar kind of peace, isn't there? A sense of our tiny, tenacious human spirit, stubbornly shining its little light into the overwhelming darkness, not necessarily expecting to illuminate everything, but finding a profound satisfaction in the act of looking itself. The next century in space will undoubtedly be filled with moments of triumph, scientific breakthroughs, engineering marvels, perhaps even those first human footprints on another world. There will be headlines, celebrations, moments that shift our collective understanding of our place in the cosmos. These are the grand dreams that propel us forward, the shiny, hopeful baubles that capture our imagination. And they are important. They speak to the best of our aspirational nature. But alongside these triumphs, the universe will continue to serve up its ouch moments, its subtle and not so subtle reminders of reality's fine print. The challenges of interplanetary travel will remain immense. The search for life may yield profound silence, or answers more unsettling than we anticipate. The fundamental mysteries of the cosmos will likely deepen even as we chip away at their edges. Our most ambitious plans will encounter setbacks, budget cuts, and the sheer, stubborn refusal of physics to bend to our will just because we really want it to. This is the cosmic buzzkill, the dose of realism that keeps our feet metaphorically on the ground, even as our minds reach for the stars. And it's in the acceptance of this duality, the awe and the ouch, the wonder and the wry acknowledgement of our limitations, that a deeper, more resilient kind of serenity can be found. We don't need the universe to be a gentle, welcoming playground, designed for our comfort and convenience. We can love it for what it is: vast, beautiful, terrifying, indifferent, and endlessly fascinating. Our place within it may be small, perhaps even statistically insignificant on a galactic scale. Our lifespan a mere blink in cosmic time. But for this brief moment we are here. We are conscious. We can look up, we can wonder, we can learn, we can dream, and we can even share these cosmic bedtime stories. The next 100 years will unfold, 1 second, 1 orbit, 1 discovery at a time. Some of what we've discussed tonight will come to pass, perhaps in ways we can't yet imagine. Other dreams may remain just that, dreams. And new, unforeseen wonders and challenges will undoubtedly emerge. That is the nature of the journey. It's unwritten, unpredictable, and all the more compelling for it. So, as you allow yourself to fully surrender to the pull of sleep, let these thoughts settle gently. Let the grandeur of the cosmos provide a vast, peaceful backdrop to your rest. Let the human ambition inspire you, and let the universe's indifference grant you a strange kind of freedom. Freedom from the need to have all the answers. Freedom from the pressure of ultimate significance. Your significance is here, now, in your own life, your own consciousness, your own capacity for wonder and for rest. The cosmos will keep its own counsel, run its own gargantuan, incomprehensible errands. It managed perfectly well before we started launching rockets and worrying about dark energy, and it will manage perfectly well long after our fleeting century has passed. Tonight, we've simply taken a gentle stroll through its potential near future, a future that is both excitingly within reach and comically out of our ultimate control. And that, my friends, is a perfectly good place to let go, to release the day, and to drift into the deep, dark, and wonderfully restorative ocean of sleep. The universe will still be there when you wake, with all its beauty, all its absurdity, and all its invitations to dream anew. And so, dear cosmic voyager, the narrative of the next 100 years fades into the quiet hum of the present moment, into the soft darkness that cradles you. The comets will continue their ancient paths, whether we watch them or not. Mars will remain its cold, rusty self, patiently or impatiently awaiting our hazardous, hopeful incursions. The asteroids will continue their silent cosmic ballet, mostly missing us, thankfully. And the great, indifferent galaxies will continue their slow, majestic spin, utterly untroubled by our fleeting anxieties or our fleeting triumphs. As you drift now, truly drift, let the sheer, overwhelming scale of it all be a comfort. Your worries, your stresses, the little insistent naggings of your day, see them as tiny, distant sparks against the backdrop of infinite night. They are there, yes, but they are so very small. The universe, in its vast, cold, beautiful indifference, doesn't ask you to solve its mysteries tonight. It doesn't demand your attention for its grand, unfolding drama of dark matter and accelerating expansion. It simply offers a space, an infinite canvas upon which your own consciousness can rest and recuperate. Remember that even as we dream of reaching out, of understanding, of perhaps finding we are not alone, the most profound journey is often the one inwards, into the quiet stillness where true peace resides. The universe is breathtakingly beautiful, yes, and it is also constantly, casually, demonstrating its power to crush, irradiate, freeze, or simply ignore us into oblivion. It's a grand, terrifying, and often hilariously absurd stage. But tonight, in this safe haven of your mind, within the sanctuary of your rest, none of that magnificent, chaotic, indifferent power can truly touch you. You are an observer, a dreamer, a tiny, precious speck of awareness, and for now, your only task is to let go. Sweet dreams. You've navigated a century of cosmic possibilities. You've certainly earned them. The stars will keep their silent watch. Sleep now. Sleep deep.